Yeah, good evening. So last class we discussed about electric field intensity. Electric field intensity. So what is electric field intensity? Just let us revise. So electric field intensity at a point is the force per unit charge when placed in the electric field. So that is, let us say you are having a charge Q at this point, and now around this charge there will be certain amount of electric field associated with this. Okay, now this is the source of electric field. So the charge Q is the source of electric field. So let us consider a point here. So at this point I would like to find out the force per unit charge. So this is the reference point where some charge is existing. This is a point of interest where we would like to find out the electric field intensity. So then we will draw a vector. So let us say this is R bar. Now the electric field intensity at this point is given by E bar is equal to Q by 4 pi epsilon A R bar by R square. So this is the expression for the electric field intensity due to a point charge. Okay, and electric field intensity is having units of newtons per coulomb or volts per meter. Okay, so this is what we are discussing. So this is the definition. So electric field intensity at any point is nothing but the force per unit charge when placed in the electric field. Okay, so if you want to find electric field intensity at a point, so in that region there should be a charge which should be existing earlier, so which gives the intensity. Okay, right? So in whatever region, if you want to find out electric field intensity at a point, there should be a charge existing already. Okay, now in this case Q is the charge already present in this region. So in the vicinity of Q we have taken a point P here. Okay, so at this point we are finding the electric field intensity due to this charge which is already existing here. Okay, right? So that is electric field intensity. Okay, so now, so till now we just we talked about point charges, but unlike point charges which occupy a very negligibly small physical area, okay, right, charge may be distributed over a line or a surface or a curve. Okay, so these are called as different charge distributions. Okay, so charge distributions. Okay, so let us say this is some line, and consider that charge is distributed evenly. So there's some charge, positive charge, some charge is distributed evenly on this line. Okay, right? So let us say this is from A to B. Now the charge is distributed evenly on this line or curve. This is what we call as a line charge. So for this, for describing these type of charge distributions, that means when charge is distributed evenly on a line or a curve, a parameter is required to represent how charge is distributed on this line. Okay, so for a line charge, this is a line charge. So for a line charge, the parameter is line charge density, and it is indicated by rho L, and it will be having units of coulomb per meter. Okay, why coulomb per meter? Because we are calling it as line charge density. The dimension of a line is its length, so length will be having units of meters. So for a charge which is distributed over a line, the parameter used to represent the charge is line charge density, and it is denoted by rho L, coulomb per meter. Okay, so now let us consider a small differential element of length dl. Okay, right? So consider small differential element of length dl. So hold on one second. So I will write down this dl on the other side. Okay, so this is differential element of length dl. Okay, so which is having or located at some point here. So this is the reference point of the dl. Okay, now the differential amount of charge, that is dq. So dq is the differential amount of charge on the differential amount of length dl, so which is given by rho L into dl. So if you see the units of rho L, it is having coulomb per meter, and dl will be having units of meters, so units will be coulombs. So this is the differential amount of charge on a small differential element of length dl. So if you want to find out the overall charge existing on this line or curve, so then what I have to do is I have to apply line integral, open line integral. So q is equal to, so q is the total charge on this line charge, which is integral over the line rho L dl. Okay, so because q is equal to integral dq, where dq is equal to rho L dl. So the total charge, this is the total charge on the line, is given by q is equal to integral rho L dl. Now this line charge is a source of electric field. Now if you would like to find out the electric field intensity due to this line charge at a particular point, then what is the expression? So let us say this is the point of interest, that is at this point I would like to find out the electric field intensity due to this line charge. Okay, so for that what we need to do is, from the reference point of dl we should draw a vector. So let us say this as r bar. Okay, so this is a distance vector joining the reference point where dl is existing to the point of interest P, where we would like to find out the electric field intensity due to this line charge. Okay, so what is the general expression for electric field at a point? It is given by q by 4 pi epsilon a r bar by r square. So where r is the distance between the reference point and the point of interest. Now in this case the charge q is not a point charge. Earlier q is a point charge. Now in this case the charge q is the total charge on the line given. So for a line charge distribution, so this is a line charge distribution, the electric field intensity at a point is given by integral rho L dl by 4 pi epsilon r square a r bar. So this is the expression for electric field intensity at a point due to a line charge distribution. Okay, so only thing we have done is we have replaced q with the charge existing on this line, which is integral rho L dl. Okay, so this is about line charge distribution. Okay, so similarly what we can do is, charge may be distributed evenly on a surface also. Okay, so let us consider if the charge is distributed evenly on a surface. So now let us take some surface. So this, let us say this is some surface. Okay, now let us say charge is distributed evenly. Okay, so charge is distributed evenly on this surface. Okay, so now this is a surface S. Now surface is having a dimension of area. Okay, so the charge distributed on a surface is represented by a parameter called as surface charge density. So surface charge density, which has units of which is denoted by rho s, and units of coulomb per meter square. So because the dimension of surface is area, and area will be in the units of meter square, and this is the surface charge density, so which is denoted by rho s and having units of coulomb per meter square. Okay, so this is a surface charge distribution, and the surface charge distribution is represented by a parameter surface charge density. Now in this charge, again what we will do is we will take a small elemental area. Okay, so let us call this elemental area as ds. Okay, right. Now the differential amount of charge ds is containing is given by dq is equal to rho s into ds, because rho s is having units of coulomb per meter square and ds is having units of meter square. Overall it will be coulombs. Okay, so this is the differential amount of charge existing on the differential amount of differential area ds. So if I would like to find out the total charge on this surface, then in that case q is given by surface integral dq, which is surface integral rho s ds. So this is the total charge on this surface, right? Now we will use this result to find out the electric field intensity at a point due to the surface charge distribution. Now this surface charge distribution is the source of electric field. Now this is the source. Now let us consider a point, some place. Let us say this is the point of interest. So at this point I would like to find out what is the intensity of the electric field due to this surface charge distribution. So now this surface charge distribution is the source of the electric field. So I would like to find out its intensity at this point P. So again what we will do, we will draw a vector from the reference point of differential surface area to the point of interest. Let us say again this is r bar. Now again using the same relation, for a point charge E bar is equal to q by 4 pi epsilon r square a r bar. Now we will replace this q with the q we got for the surface charge distribution. So substituting here, for a surface charge distribution, the electric field intensity at a point is given by integral over s rho s ds by 4 pi epsilon r square a r bar. So this is the relation which we use for finding the electric field intensity at a point due to a surface charge distribution. Okay, right? So this is the expression for electric field intensity due to surface charge distribution. So like surface charge distribution, we may have volume charge distribution also. That means charge may be distributed evenly inside a volume. So now let us consider some volume. Let us say some volume. Okay, so this is some volume, and let us say that charge is distributed evenly in this volume. So in this volume, let us say charge is distributed. Okay, now volume will have a dimension of obviously it's a volume, it will be having its units as meter cube. So if a charge is distributed evenly or uniformly inside a volume, then the charge is described by a parameter called as volume charge density. So volume charge density is indicated by rho v and units will be coulomb per meter cube. So this is volume charge density. Now if I take a small elemental volume in this, so if I consider some small elemental volume in this, okay, small elemental volume. So small elemental volume is dV, this entire volume is V. So the amount of charge, differential amount of charge contained in the differential volume dV is given by rho v into dV. Okay, now the total charge Q in this entire volume V is given by integral V rho v dV. Okay, so this is the total charge contained in this volume. Now we will use this result to find out the electric field intensity at a point due to this volume charge distribution. Okay, so for a point charge, E bar is given by Q by 4 pi epsilon R square AR bar. So first of all, we will write down the point of interest. Let us say this is the point P where we would like to find out the electric field intensity. So I would like to find out electric field intensity at this point due to the volume charge distribution. Now this volume charge distribution is the source of the electric field. So this is the source which is creating the electric field, and we would like to find out what is its intensity at this point. So draw a vector from the differential volume reference point to the point of interest. Let us say this as R bar. Now using this result of charge inside a volume, so electric field at a point due to the volume charge distribution with volume charge density rho v is given by integral over v rho v dv by 4 pi epsilon R square AR bar. So this expression gives us electric field intensity at a point due to the volume charge distribution with volume charge density rho v. Okay, so we will use this result to find electric field intensity due to different types of charge distributions in the next class. Okay, thank you.